Hello everyone, welcome back to my YouTube channel. So today we'll be discussing a long chapter of community medicine, that's environment and health, which is very important for spotters especially, and many trick questions in competitive exams. So first we'll start with water. So we have the sources of water: rain, surface water and groundwater. Surface water can be found in impounding reservoirs, rivers, streams, tanks, ponds and lakes. Groundwater can be broadly divided in shallow and deep wells and springs. Of course, we have the sea also for surface water. And then wells can be classified into deep and shallow wells, or into dug wells and tubed wells. Dug wells are the most common wells found in India, and we have kacha and pakka wells. And then we also discuss what's a sanitary well and the various components, that is the location, lining, the parapet wall, platform, drain, covering, hand pump and consumer responsibility. These are important requirements in ensuring the cleanliness of a sanitary well. We also have a tube well, in which the parts and structure and few pros and cons are discussed. And then we have springs. Next we deal with water pollution, which will be biological, by infective agents or aquatic hosts. We have viral, bacterial, protozoal and helminthic agents. And under aquatic hosts, we have snails that can transmit schistosomiasis and cyclops, which can transmit guinea and fish tapeworms. We then discuss the effects of various chemicals on our health, how fluoride influences dental health, how nitrate can cause cyanosis in infants, and how hard water is protective for the heart and cardiovascular system. There are various diseases that can spread due to inadequate water usage, like trachoma, shigellosis, ascariasis, and scabies. We then have the 1974 Water Prevention and Control of Pollution Act. Then we have water purification, which can be divided into large scale and small scale purification. In large scale, we have storage, filtration, and disinfection. These are the steps. So, under filtration, we have slow sand filters and rapid sand filters. These are important topics. Slow sand filters have four main components: the supernatant, a bed of graded sand, an under drainage system, and a filter control valve system. And both the sand filters have diagrams, which you should know, and the various advantages and disadvantages of both. And the steps in rapid sand filtration, which involve coagulation, rapid mixing, flocculation, sedimentation, and filtration, plus a short note on what is backwashing. Then we learn about what's disinfection, the criteria for disinfection of water, and the various measures like chlorination, ozonation, and membrane processes. So we also have the principles of chlorination and various methods of chlorination by using chlorine gas, chloramine, or perchloron. And then we also learn what is breakpoint chlorination and superchlorination. And to test the adequacy of chlorination, we have orthotolidine and orthotolidine arsenide tests. Then, under membrane processes, we have high pressure and low pressure processes. High pressure membrane processes are osmosis, reverse osmosis, and nanofiltration. Low pressure processes are ultrafiltration and microfiltration. Next, we talk about well disinfection, in which here also we have steps, in which we have to assess the volume of water required, the amount of bleaching powder required, the process of dissolving the powder in water, the delivery of chlorine solution into the well, the contact period required, and then finally, of course, the orthotolidine arsenide test. So that's the end of large scale purification. Now for small scale purification, we have household and wells. So household, the measures we have boiling and chemical disinfection using bleaching powder, chlorine solution, high test hypochlorite, chloride tablets, iodine and potassium permanganate. Then we have filtration, UV radiation and multi-stage reverse osmosis. Under filtration techniques, we have Pasteur Chamberlain filters, which are the famous candles that you know, and Berkefield and Catadine filters. This one small part I forgot to mention. Now, proceeding to water quality, there are 4 important criteria aspects of good quality of water. Firstly, we have acceptability, microbiological, chemical, and radiological aspects. So, under acceptability, we have physical constituents and inorganic constituents. Under physical factors, we have turbidity, color, taste, odor, and temperature. And under the inorganic constituents, we have chloride, ammonia, pH, hardness, hydrogen sulfide, iron, sodium, sulfate, manganese, aqueous oxygen, copper, aluminium, and total dissolved solids. Under microbiological aspects, we have bacteriological, virological, and biological. With this basically parasites. So under bacteriological, we have coliforms, fecal streptococci, and Clostridium perfringens. Under biological, we have protozoa, helminths, and other free living organisms like algae and fungi, etc. Now, under chemical aspects, we have inorganic and organic constituents. Inorganic has arsenic, cadmium, chromium, cyanide, fluoride, lead, mercury, nitrates and nitrites, and selenium. The important ones I have circled here. And under organic constituents, we have chlorinated alkanes and ethers and aromatic hydrocarbons, especially polynuclear aromatic hydrocarbons or PAH, in which the most infamous one is benzoapyrin, which is known to cause malignancies in mice when taken orally. Then we move on to surveillance of water quality, in which there are 3 things: sanitary survey, sampling, and bacteriological surveillance. Under bacteriological surveillance, we see the colony count, we examine for fecal streptococci and Clostridium perfringens, and we also do presumptive coliform tests, which have 2 methods: multiple tube and membrane filtration method. We also discuss about hardness of water, which can be temporary or permanent. Temporary hardness is by carbonate or bicarbonate ions, and permanent hardness is due to sulfate or chloride or nitrate ions, along with the cations that are calcium and magnesium. We also talk about the disadvantages of using hard water. While the advantage is that it's cardioprotective, and it's classified into, water can be classified based on hardness into soft, moderately hard, hard, and very hard, according to a classification that's given in the textbook. Special treatment measures for water include one, of course, we discussed hardness right now. So hardness removal, to remove temporary hardness, we can boil, we can use lime, we can use sodium carbonate, or we can use permutate or box exchange process, and which is applicable for both temporary and permanent. Then for permanent exclusively, we have sodium carbonate as well. We also have fluoridation and defluoridation. Next, moving on to the distribution of water. So there are 2 types of water supply: continuous and intermittent. Continuous is recommended, and intermittent is not, because it harbors the multiplication of microbes. And then there are short notes on swimming pool sanitation, Horrocks apparatus, which is very important, sampling of water, how it's done from the tap, from water bodies, transport and storage, and water conservation to prevent wastage and ensure harvesting of water. We move on to the next component of the environment, that is air. So we see the composition of air and what exactly is discomfort with respect to air. And we discuss the indices of thermal comfort at air temperature, temperature plus humidity, cooling power, effective temperature, corrected temperature, which we also learn about Macardle's maximum allowable sweat rate, plus the various comfort zones. There's a small table in the textbook, which not usually asked but recommended to know. And then we talk about air pollution, in which we define primary and secondary pollutants, gaseous pollutants and particulate pollutants, and their effects on local, urban, regional and global scales. And the various sources of air pollution, which are automobiles, industries, tobacco, something that's frequently overlooked in our society, domestic sources also, and miscellaneous, plus other meteorological factors that can affect air pollution, how air pollution affects the region. Then we want to discuss the actual pollutants themselves, like carbon monoxide, sulfur dioxide, lead, carbon dioxide, hydrocarbons, cadmium, hydrogen sulfide, ozone, oxides of nitrogen, PAH, and particulate matter. Here are the important ones I have circled again. And then we also talk about indoor air pollution, and then the monitoring of air pollution, which can be done by monitoring the SO2 levels, smoke or soiling index, grit and dust measurement, coefficient of haze, and air pollution index. Then we also see the effects of, before the effects of health, we also learn what is CPCB, the Central Pollution Control Board, and which works with the National Air Quality Monitoring Program. Now coming to the effects of air pollution on health and socio-economic aspects of society. Health, it can have acute and chronic effects. And the prevention and control, we have measures, we have containment, replacement, dilution, legislative measures, and internal action. Then there's also note on disinfection of air, in which we talk about mechanical ventilation, ensuring adequate ventilation basically. Then ultraviolet in disinfection, chemical mists, and dust control. We then move on to ventilation. What are the standards of good ventilation? So it's described in terms of three things: cubic space, air change, and floor space. And then the types of ventilation are that can be natural, which consist of wind, diffusion, and temperature difference or inequality. Then we have mechanical ventilation, which includes exhaust, a plenum or centrifugal fans, and balanced ventilation and air conditioning. So these are the requirements for air change and floor space, which are written 1000 to 2200 cubic feet per person and 50 to 100 feet square floor space per person. So that's all we need to know in ventilation. Now in lighting, we have the requirements of lighting, which include sufficiency, distribution, absence of glare, absence of sharp shadows, steadiness, light color, and surroundings. Then the measurement of lighting. Before that, the very small requirements that you need to know. Sufficiency, 15 to 20 foot candles is the minimum requirement. And under surroundings, you have reflection factors, or that ceilings should reflect 80% of the light, walls 50 to 60%, and furniture 30 to 40%. Now coming to how we measure the lighting. We have luminous intensity, luminous flux, illumination or illuminance, which measures the light reaching a surface, measured in lux per area, and then brightness or luminance, which you have light reflected from a surface or area, that's measured in lamberts. Next, we also have natural lighting improvement measures that consist of improving the orientation, removing any obstructions in the path of light, ensuring adequate large size of windows, and good room interior designing. Under luminous flux, we have another topic called daylight factor, which is equal to the instantaneous illumination indoors by simultaneous illumination outdoors into 100. It's measured using a device called the daylight factor meter, or DF meter. Coming to artificial lighting systems, they can be classified into direct, semi-direct, indirect, semi-indirect, and direct-indirect. And the methods of are lamps, in which can be filamentous lamps or fluorescent lamps. So the standards of illumination, our eyes respond to this range: zero point 0.1 lux, that is full moonlight, to 100,000 lux, which is bright sunshine. So ideally we need 30 times the lighting than what's required for a particular task in our workplace to ensure optimum productivity. The human body experiences few biological effects of lighting. 4 important ones are mentioned in the textbook. The phototherapy in jaundiced infants, the very synthesis of vitamin D, the sunshine vitamin, adrenocortical secretions, that they have a diurnal variation, and how it affects food consumption. These two are basically due to the diurnal variations. Next we have noise. What is noise? What are the properties of noise? Loudness, plus amplitude and frequency. Loudness is measured in decibels. 85 decibels is the recommended maximum, and 140 decibels is the pain threshold. And the frequency, the human range of hearing is between 20 to 20,000 hertz. And the effects of exposure can be auditory and non-auditory. Non-auditory effects are speech interference, annoyance, decreased efficiency of work, and various physiological effects. So how do we control noise? Effective city planning, vehicle control, basically traffic control, acoustic insulation of buildings, stricter rules for industries and railways to control noise, ensuring adequate protection of those who are exposed to noise on a daily basis, and adequate implementation of legislative measures and health education on the same. Next we come to radiation, or the sources of radiation. They can be natural or man-made. Naturally we have cosmic rays and environmental like terrestrial and atmospheric sources. Man-made we have X-rays, radioactive fallouts, and other miscellaneous sources. Broadly we can classify radiation into electromagnetic radiation, which consists of X and gamma rays, and corpuscular, which include alpha rays, beta rays, basically electrons, and protons. Radiation units, we have becquerel, Roentgen, rad, rem. These three measure the potency, and dose equivalents measured in sieverts. So the biological effects can be classified into somatic and genetic. Somatic, we have immediate and delayed effects. Immediate effects are radiation sickness and acute radiation syndrome. Delayed effects are leukemia, carcinogenesis, and teratogenesis. Genetic effects, we have chromosomal anomalies and point mutations. So here, responses to different levels of radiations, in which are graded in this manner. More than 2000 rads, it is lethal, inevitably lethal. And we also discuss about the various protective measures that people routinely exposed to radiation have to undergo. Now coming to the meteorological environment, we talk about atmospheric pressure, air temperature, humidity, precipitation, direction and speed or velocity of wind, and movement of clouds and characteristic of weather. Under atmospheric pressure, we have to define atmospheric pressure and how we measure atmospheric pressure, and the effects of high altitude and low altitude on health. Next we have air temperature, which in detail we learn about how we measure air temperature, what is heat stress and cold stress, and global warming. So air temperature is measured using the following devices. They're all thermometers basically: dry bulb, wet bulb, maximum thermometer, minimum thermometer, 6 max and minimum, globe thermometer, wet globe thermometer, silvered thermometer, and Carter thermometer. Of these, dry bulb, wet bulb, globe, and Carter are important. They can be asked in spotters sometimes. Under heat stress, we have the indices of heat stress: equatorial comfort index, heat stress index, and the predicted 4-hour sweat rate. And the effects, we have heat stroke, heat hyperpyrexia, heat exhaustion, cramps, and syncope. So how do we prevent heat stress? There are 5 measures: water replacement, regulation of work, clothing, protective devices, and ensuring a cooler work environment. Now, too much of cold is also not good. Too much of anything is too bad. So, we have cold stress, which can cause trench foot or frostbite, and a brief note on how do we manage the two. We move on to discuss humidity. What is absolute humidity, relative humidity, and dew point humidity, and how do we measure humidity? We use a dry and wet bulb hygrometer, a sling psychrometer, and an Assmann psychrometer to measure the same. So I forgot to discuss this. The precipitation, here the definition and measurement of precipitation, different forms of precipitation: rain, snow, hail, dew, and frost. Now moving on to housing, we have social goals for housing, the criteria for helpful housing, and the various housing standards, including site, setback, floor, walls, roof, rooms, floor area, cubic space, windows, lighting, kitchen, a privy, garbage and refuse, bathing and washing, and water supply. Next, we talk about overcrowding, the definition of overcrowding, and how it's discussed in terms of people per room and floor space. So, for one or more than 5 rooms, if the number of rooms is n, having more than 2n people in that room is considered overcrowding. In that number of rooms is considered as overcrowding. So, for 2 to 4 rooms, 2n minus 1 people in those many rooms is considered overcrowding. So coming to floor space requirements, for 2 people 110 square feet, 1 person 70 to 90 square feet, half person, that is basically anyone aged below 10 years, and less than 50 square feet for anyone aged below 12 months. So the indicators of good housing are physical, economic, and social. Social, we have prevention of illness, and comfort, and mental health and social well-being. These are further things that are discussed more in detail, which too much to represent here. Then we also have public policy of housing by the Ministry of Works and Housing. Next up, we have waste disposal, in which we talk about solid waste, how we are to store waste, how to collect, and how the methods of disposal. There are dumping, controlled tipping, sanitary landfills, incineration, composting, which are anaerobic methods and aerobic methods. Under anaerobic, we have the Bangalore method of composting, and manure pits and burial. We'll talk about public education, the economics and finance, and international cooperation regarding waste management. So what are the sources of solid waste in the first place? There can be domestic refuse, industrial refuse, stable litter, market refuse, and of course street litter. Domestic refuse can be classified into ash, rubbish, and garbage. Next up, we have sewage disposal. We talk about the public health importance of sewage, which causes soil pollution, water pollution, food contamination, and propagation of vectors, mainly flies, when not disposed properly. Then we talk about the transmission of various diseases, how diseases can be transmitted from feces to various hosts via water, fingers, flies, and soil, and of course in between food. So we need to know something called a sanitation barrier, which can be described in this diagram as follows. So ensuring an adequate sanitation barrier is vital in preventing transmission of various communicable diseases. So what are the methods of sewage disposal? Firstly, in unsewered areas, we have service type latrines, non-service type latrines, and latrines suitable for camps and temporary use. In the service type latrines, we have the conservancy system, and non-service type latrines, we have boreholes, dug wells or pits, water seal latrines, which are into three types: PRAI, RCA, and Sulabh. Sulabh Shochalaya, that we all know. Septic tanks and aqua privis. And for latrines suitable for camps and temporary use, we have shallow trench, deep trench, pits, and boreholes. So what is PRAI? PRA is the Planning, Research and Action Institute in Lucknow, and RCA is Research cum Action Projects in Environmental Sanitation, which is under the Ministry of Health and Family Welfare. RCA latrin is discussed a bit in detail in this book. So we have to know the location, what's the squatting plate, pan, trap, connecting type, dug well, and what's the superstructure and how its maintenance is carried out. Even for a septic tank, we have to know the design, working, operation and maintenance of a septic tank. Of course, for all the latrines, we need to know the diagram as well. Under sewered areas, we have water carriage system and sewage treatment. So we have primary, secondary and other methods of treatment. So primary treatment is consisting of screening, grit removal and plain sedimentation. Secondary treatment involves trickling, filters and an activated sludge process. And other methods include sea outfall, river outfall, sewage farming and oxidation ponds. So we then discuss the components of a water carriage system, which include household sanitary fittings like your sink, commode, etc. House sewers, street or trunk sewers, and sewer appurtenances, which include manholes, traps, etc. We then move on to discuss the environmental friendly bio toilet, which is now a staple across all trains in Indian Railways, which has reduced the fall of organic matter onto tracks. So with the pros of the bio toilet, the mechanism, which involves a small flow chart in the text, which is given in the textbook, and the residue water properties, which are how it's safer. We then move on to the definition, health aspects and composition of sewage and the various processes, aerobic and anaerobic. So what are the aims of water purification? Why do you purify? You want to reduce the biochemical oxygen demand, you want to reduce the chemical oxygen demand, and reduce the amount of suspended solids present in the water. There's also an important flow diagram showcasing how it's treated. And the other few processes that come in between secondary sewage treatment and the other methods, which is secondary sedimentation, sludge digestion, disposal of effluents, that's by dilution on land or other methods, which are the one which we discussed above, and the social aspects of secondary sewage treatment. Now we move on to one of the most important parts of this chapter, especially in terms of practicals, entomology, the study of insects. We'll be discussing many insects today. So we'll start with, I'll just briefly list down: fleas, human lice, flies, which are housefly, sandfly, the tsetse fly, and black flies, and the most important and most annoying of them all, mosquitoes. So mosquitoes can be broadly classified into Anopheles and Culicenes, which includes Aedes and Mansonia. So before that, we talk about the transmission of insect-borne diseases by direct contact, mechanical and biological transmission. Biological transmission can be propagative, cyclopropagative, and cyclodevelopmental. Then we have principles of arthropod control, which include environmental, chemical, biological, and genetic measures. We also learn what is an extrinsic incubation period, an intrinsic incubation period, and what's an intermediate host. Then we move on to description of each type of mosquito, and how we differentiate between Anopheles mosquitoes and Culisine mosquitoes, then the life cycle and the various habits of a mosquito, feeding habits, bite habits, resting, breeding, hibernation, and dispersal habits, the various diseases each type of mosquito can spread, and the control measures, which can broadly be classified into anti-larval measures, anti-adult measures, and personal protective measures. Under anti-larval, we have environmental, chemical, and biological control. Under anti-adult measures, we have residual sprays, space sprays, and genetic measures. Under personal protection, we have mosquito nets, repellents, and screening. Screening refers to like an actual screen. It's basically the mesh that you see in windows and doors. Now coming to flies. In flies also we have the anatomical description of each type of fly, the life cycle, their habits, the diseases they transmit, and control measures, which will be environmental, insecticidal, fly papers, protection, personal protection, and health education. Under insecticidal measures, we have residual sprays, bats, which are available for mosquitoes also, baits, actually this one, cords and ribbons, space sprays, and larvicides. And the human lice, we have head and body lice and the crab lice, which are also discussed on the similar headings, with a special note on control, which can be insecticidal. And for head and crab and body lice, we use malathion, and personal hygiene on how to prevent a lice infestation in the first place. Under fleas, besides the usual headings, we have the flea indices, which are the general flea index, specific flea index, percentage incidence of flea species, and rodent infestation rate. And of course, control, insecticidal control, repellents, and rodent control. Insecticides, we have carbaryl, diazinon, and malathion. Of course, a small note on patch dust. Then we have reduvid bugs, and then we have ticks, hard and soft ticks. How do you differentiate between hard versus soft ticks, and the diseases they transmit? We have mites, which we have tromiculid mites and itch mites, and management of scabies, which mites transmit. The drugs used are benzyl benzoate, gamma HCH or lindane, tetmozole, and sulfur ointment. For both, we have insecticidal control, environmental control, and worker protection. Next, we have cyclops. So the control of cyclops include physical measures like straining and boiling water before usage, and chemical measures like chloride, lime, and abate. Then biological measures by introducing fish which feast on cyclops. Next, we move on to insecticides, which are discussed in detail in this chapter. The classification of insecticides, how resistance against insecticides is a matter of concern. Mainly DDT and analogs and the HCH dieldrin group are experiencing resistance today. We will also talk about organochlorine toxicity and organophosphate or carbamate poisoning. It's an important topic both in this subject and in forensic medicine as well. So contact insecticides are natural and synthetic, stomach poisons, and fumigants. Under fumigants, we have hydrogen cyanide, methyl bromide, sulfur dioxide, and carbon disulfide. Stomach poisons, Paris green, and sodium fluoride. Natural, we have pyrethrum, rotenone, deres, nicotine, and mineral oils. Synthetic, we have organochloride compounds, organophosphate compounds. Organochloride compounds are DDT, lindane, dieldrin, and methoxychlor. OPC compounds, we have malathion, phenetrathion, abate, dichlorvos, and parathion. Next category, we have carbamates, which consist of carbaryl, dimethylan, pyrolan, and propoxyur. Repellents, we have benzyl benzoate, indolone, and metadiethyl toluamide. Synthetic pyrethroids, we have resmethrin, bioresmethrin, othrin, and permethrin. Next, we discuss another important pest, that are rodents, which will be domestic or wild. We also deal with the diseases they transmit and various anti-rodent measures that can be undertaken, like sanitation measures, trapping, using rodenticides, fumigation using a cyanogas with a pump, chemostimulants. Rodenticides can be classified by WHO based on their acute effects on human health into those which require ordinary care, like precautions to safeguard against toxicity, like red squill and zinc phosphide. Rodenticides which require maximal precautions like sodium fluoroacetate and strychnine. And finally, those which are too dangerous for use, like arsenic trioxide, phosphorus, glyphosate, thallium sulfate, and ANTU. In India, the common rodenticides used are barium carbonate, zinc phosphide, and multi-dose or cumulative poisons like warfarin, difascinone, and cumafuril, which are basically anticoagulants. And then, lastly, we have a small note on zoonosis. What are the various zoonotic diseases and their respective control measures? They can be categorized into bacterial, helminthic, protozoal, and viral. So that completes this chapter, and that's it for today, guys. Hope this is helpful. See you soon. Thank you.